All of your argument is only to try to rescue time. You need billions of years. Okay, I'll give you billions of years. How do you turn an amoeba into a whale over trillions or quadrillions of years? You're only trying to rescue time because you know how desperately you need time. Okay, I agree there's variations within the same kind. There's different types of dogs. Do you mean that is enough to convince you that dogs are related to cabbage? Do you believe you are related to cabbage? There are 6 different levels or stages of evolution. If you don't like it, too bad.
Well, rest easy, Kent. You can rest easy tonight because none of that, what you teach about the 6 levels, is being taught in the universities. None of it is being taught in the textbooks.
Where did the energy come from?
The Big Bang, I don't know. The Big Bang does not even try to address that. Now, there are science.
So we got our princess on the island in a golden castle, and you want to start from there. We're going to eat your cousins tomorrow for lunch, cabbage. I'm sorry about that. Go ahead.
Hello, Kent.
Hi. I know, you're calling in to announce you got converted.
No, not today.
Okay. You better before you die. I would highly recommend it, but go ahead.
This, measuring using parallax. Now, you've been told, you don't use parallax to measure very distant stars. You use standard candles.
So you're telling me you can tell how far away a star is by how bright it is. Are all the stars in the universe burning at the same brightness right now, regardless?
No, you use type 1A supernova, and it's the same as the inverse square law applies, and you know that it applies to light.
Okay, now just slow down. Now you're telling me that you can tell how far away a star is by how bright it is. Is that your position?
Type 1A supernova. Yeah, that's a standard candle.
So you can tell by how the luminosity, the candle power of that star determines the distance. Wouldn't that be assuming that you already know what type star it is? How do you know what type star it is?
The type 1A supernova, and using the inverse square law. You seem to be all over the inverse square law when you talk about the moon. Okay, but now you're going to deny it when it comes to starlight.
I'm not denying anything. I understand the inverse square law. It's got nothing to do. My question was, you are claiming that you can tell the distance to a star based on how bright it is. And you can tell what type of star it is.
Yes. The scientists know very well how to measure the distance of a star using the brightness, using the standard candle.
Okay, let's assume that we do know the distance to the star. Does that therefore tell us the age? How long it took the light to get here? Wouldn't that be assuming that the speed of light's always been consistent?
Well, if you want to mess with the speed of light, you know that E equals MC squared, right?
I understand. Yeah.
So M equals E divided by C squared. You adjust C.
Einstein's theory, right? This formula. Yep.
Right. Yeah. If you manipulate C, you change the value for mass as well. To get starlight from the edge of the visible universe to the Earth, you're going to have to increase the speed of light by 2.3 million, a factor of 2.3 million. You do that, you increase the mass as well, and you affect the mass, you're going to destroy the universe. It's a bad approach.
Well, yeah, I think you have a bad approach, correct. I think Einstein's formula, E equals MC squared, the energy is the mass times the speed of light squared. I think that was just an example. I don't think that's an exact number. You're saying the speed of light squared is exactly, that's just an example of how much energy and mass, how they're related to each other. He could have said E equals MC cubed.
Real math, you can go you prove Einstein wrong and collect your Nobel Prize.
I'm not saying he was wrong. I'm saying he was giving an example of how much energy and mass, how they're related. The energy is equal to the mass times this huge number squared. He could have said E equals MC cubed. And still, we get the point across. You don't know that it's exactly MC speed of light squared, do you? Does anybody know that? How could you know that?
Well, then I guess, like I said, you do the math. Show us the real math. Show us the Hovind math and how it gives better predictions and gives better results than, relativity.
Well, first of all, I will say mass, I can take a pile of wood and burn it and produce energy.
That's a chemical reaction.
Can you take the energy and produce mass? Show me any place where energy has been used to produce mass. Just energy.
The Hadron Collider.
The Hadron Collider is taking energy and producing mass from it. Is that what you're saying?
Yes.
Okay, I think I'd have to disagree. I'll look into that more. But
okay, look into it. Now, as far as this speeding the light up and down, that 1999 paper, it was talking about the group velocity, which is what's happening actually inside the wavelength, or the phase velocity, and that's light when it passes through a medium. The front velocity, c, was not changed in that paper. That's not what they're talking about. They're talking about increasing either the group or the phase velocity. So the front velocity, or c, no, that was not changed.
I would ask you to go to icr.org. They've got a couple of physicists on that staff there, ICR, Institute for Creation Research, and read the articles they've done on this topic. But I want to look at a little bigger picture here. All of your argument is only to try to rescue time. You need billions of years. Okay, I'll give you billions of years. How do you turn an amoeba into a whale over trillions or quadrillions of years? You're only trying to rescue time because you know how desperately you need time. Okay, for the moment, I'll say I'll give you billions of years. Now, where's the evidence of evolution is what I want to talk about. Because all you're doing tonight is trying to say, well, we got time because it took time for the Starlight to get here. I think I just showed plenty of papers where that's not necessarily the case, but it's a minor point compared to the bigger picture. Where's the evidence for evolution? That's the title of tonight's program. Evolution is a religion, and it's dangerous and it's dumb, so it should prove me wrong.
Well, you can go to Google Scholar, enter evolution into the search engine, and you're going to get tens of thousands of papers which present evidence for evolution. Now, looking at evolution, how is it defined? It is the change of allele frequencies in populations due to inherited descent. So what are you arguing? Are you saying alleles are not a thing, that they don't exist?
Oh, no, I didn't say that.
Okay, do they change variation in populations?
You are starting with living things.
That's right. That's that's what evolution is.
That's what I said at the beginning.
A scientific theory will look at one particular phenomenon. Every scientific theory is not meant, and is certainly not a theory of everything. If it is to look at germ theory of disease, you don't have to explain the origin of the universe to explain how germs cause disease, right? Mm-hmm. So evolution is not a theory designed to teach the origin of the universe. It's not a theory that handles a theory. It's not a theory of everything. It is a theory that explains variation of life here on Earth. It doesn't deal with abiogenesis. That's something different. Certainly doesn't deal with the origin of the universe.
Well, this is why I say it's a fairy tale. Let's imagine a princess on an island loaded with food and living in a golden castle. And let's start our story from there. No. Where'd the island come from? Where'd the princess come from? How'd she get a golden castle? You guys want to start with things because it is part of your theory. How did life get started?
Different theories.
You want to skip that. I know why, and I know why.
They are different theories. And if you go to a biology conference, you will not see a physicist there giving presentations on the origins of the universe or physics. You will see biologists talking about biology, and none of them are going to mention Big Bang cosmology or any of that. It's not covered, and vice versa. If you go to a physics conference, they're going to be talking about the supernova. They're going to be talking about Big Bang, perhaps. They're not going to be talking about biological evolution. Different disciplines, different theories. It's not all one big thing.
Okay, who is Lawrence Krauss? You know that name?
Yes, he's a physicist, yes.
Just as biological evolution is the heart of biology, cosmic evolution is the heart of modern cosmology.
Right, he's just talking about evolution in a colloquial sense as change over time.
Look what he said here, okay? This is in Evolution Education Outreach Volume 3, page 193 through 197. Biological evolution requires the products of cosmic evolution. Yes, they are tied together. You have
They're
to
tied
have
together in
something-
science. Science is a broad study. They're tied together in science, not in the same theory.
I agree there's variations within the same kind. There's different types of dogs. Do you mean that is enough to convince you that dogs are related to cabbage? Do you believe you are related to cabbage?
All life is related as a universal common ancestor. That is where the evidence is leading us. And if you look at the genetics, it's going to confirm that.
So let me summarize your answer. Yes, you believe you are related to cabbage, don't you? You have a common
we're both
ancestor.
we're both eukaryotes, are we not?
Why can't you just say yes? You're related to cabbage. We're both attracted by gravity.
I've been saying that. I've been saying that from the beginning. I said we are both eukaryotes. In that way, we are related, in that we are both a member of the clade eukaryota.
Hold it. Now, me and this
like cabbage.
Hang on, we're both attracted by gravity, so that proves we're related.
Being attracted by gravity is not is not something you inherit in your genes. Rocks and feathers and whatever is all, any type of matter is going to be attracted by gravity. That is not a synapomorphy.
Let me just leave you with this here. It is my position that there are 6 different levels or stages of evolution. If you don't like it, too bad.
That's not what is being taught in schools. That is something that you made up, and you are always talking about how you don't want this, thus, and so to be taught in the textbooks. Well, rest easy, Kent. You can rest easy tonight, because none of that, what you teach about the 6 levels, is being taught in the universities. None of it is being taught in the textbooks. So you can sleep easy tonight.
Okay, good. I'm surrounded by textbooks, and I can show you clearly it is, okay? They do teach in biology books. I got, 20 of them right here. They have the Big Bang in there. Why is the Big Bang in a biology book? Why don't you help me get that out?
Show. I want to see the reference.
Well, come on down. I got a huge collection. How many? I don't know how many. Several hundred biology, earth science, physical science books. I love those things.
Okay, it might be a physical science book. That some science books cover a broad range of different disciplines of science.
Here we go. Prentice Hall. Just grab one off the shelf, okay? Joint Prentice Hall. Do they talk about the Big Bang in the Prentice Hall biology book? Let me get to the index here. Let's see. The nature of chemistry, chemical evolution. Yeah.
Right. Look again, a colloquial term, change over time. We can talk about the evolution of dance. We can talk about the evolution of the Corvette, or in that way, evolution is used as a common term. Now, in biology, the theory of evolution, we're talking about the change of allele frequencies in populations by means of herited descent. That's what. For the theory of evolution, that's what we're talking about.
Okay, I understand.
Not the broad term.
Okay, I understand that my chart showing the 6 different levels of evolution triggers you guys, because it exposes the giant gaping hole you have in your logical sequence to get from nothing to living things. And I do it because it triggers you guys, and I enjoy watching you guys get triggered. It is part of the theory. You have to have something to explode. And I keep saying, where did time, space, matter come from?
It's a part of science. It's
not part of
science.
Now,
I don't mind talking about the Big Bang, but we're talking about physics. I don't mind talking about star formation.
Well, tell me, if you don't mind talking about Big Bang, what exploded and where did it come from, and what was before that?
Well, it wasn't really an explosion in the way you mean it. It's an expansion. Although the Big Bang theory explains this. How the universe was once in a hot, dense state, and it explains how it got from a small hot, dense state to its present cool and sparse state. And you can look it up, and I have. It does not address the cause of the universe. It does not try to address where the energy came from or any of that. Just like the germ theory of disease does not try to do any of that. The tectonic plate theory, where do those tectonic plates come from? You know, now we got to go all the way back to the Big Bang to understand tectonic plates. No, we don't.
So you want to start with your princess on the island in a golden castle and then go from there. I understand. Here, look at this, European Space Agency. Let's see, Joseph, blow that up so everybody can see that, would you? This is European Space Agency. Time, space, and matter all began with the Big Bang. In a fraction of a second, the universe grew from smaller than a single atom to bigger than a galaxy. And it kept on growing at a fantastic rate. And it's still expanding today. Do you believe that?
Well, that's what the physics are telling us. And as far as the space and time are intermixed. That's why they call it space time. Okay.
Anyway, all right.
So matter comes from E equals mc squared. M equals E divided by c squared. Energy and matter are also intermixed. In the beginning, there was no matter. We've gone over this before. It's pure energy, a plasma of some kind, some radiation, right?
And where did it come from? Where did the energy come from?
The Big Bang, I don't know. The Big Bang does not even try to address that. Now, there are science.
So we got our princess on the island in a golden castle, and you want to start from there.
In all these, the story like the princess on the island and the castle, you don't need to know who built the castle to tell the story, do you?
That's why evolution's a story. It's not science. Science
it is science. It makes predictions, accurate predictions, and create your creationism. The Hovind model does not.
It sure does. I predict cows will always have baby cows, no exceptions. I predict giraffes will always have baby giraffes with no exceptions. That's quite a prediction. We got a cow up on the North 40 that's pregnant right now. I bet you $500 she will have a calf, not a kitten. She's up there with the sheep, and she's up there with the donkeys and the raccoons and the possums. But I'll bet you $500 it'll be a calf when it comes out. You want to take me up on that bet?
What we're talking about, Kent, is that cows giving birth to cows, that's the law of monophyly, right? Science does not say that they won't. I'm not looking for areas where we agree. I'm looking for areas where we disagree. Now, as far as that being a prediction, that's a prediction in the same way I would say, when it rains, I predict the ground is going to get wet. That's not a scientific prediction. A prediction is stating something we don't know already, something we have not observed already. Cows giving birth to cows is something that we have observed for as long as we've been around. That is not a prediction.
You're getting it. That's all. God said in his word 20 times in the first 7 chapters, all the plants and all the animals will bring forth after their kind. Do you know of any exceptions to that we've seen? Not that you can imagine. What have we seen where any plant or animal ever produced something other than its kind? Why do you think it happened in the past? Do you think this chart teaches the students that an amoeba or a protozoa or whatever you want to start with, a single-celled creature, slowly evolved into a whale? Would you have to add something to the amoeba to turn it into a whale? Wouldn't there quite a few things have to be added to turn it into a whale? You know, like lots of things. Where's the examples of that happening? Amoeba.
You mean you're not going? You're going to go? Are you talking about going from single cell to multi-cell? Because we've already we've been over. Well, that's where it begins, and evolution doesn't say an amoeba is going to like explode into a whale, does it? So it says, you know, you're going to make small, gradual changes, and to get from point A to Z, right? We see Chlamydomonas. A single cell algae. We see it go from single cell to multi-cell by introducing a predator. right?
And that's enough to make you believe it eventually could turn it into a whale.
That's enough to believe that we do indeed have mechanisms by which
Okay.
single cell can evolve to multi-cell, true
Right.
multi-cell,
Well,
with a
we're way over time. Way over time. Call in next time. Let's take up this some more. I try to go by
Sure.
30-minute programs. It's been an hour. Okay, so I've been very generous here.
Well, thank you for entertaining me, Kent.
Yeah, and it is entertaining.
Appreciate
I
it.
love it.
Yeah,
Well,
you're
and
very
you and-
funny.
We're going to eat
Yeah.
your cousins tomorrow for lunch. Cabbage. I'm sorry about that. All right. See you tomorrow.
Okay.
Bye. Okay. Thank you, folks. See you then. Bye.